All right, greetings. Welcome to Lab 4. The first time I did this, I had this lab in here for this is the third semester I think we've done this course. And by the time I got to the fourth lab, when I was kind of building, as we say, building the plane while I was flying it, developing this course, we kind of started it and kind of ran out of gas with the first three labs. And so this lab didn't have like a pre-lab or any kind of explanation of how do rockets fly? You know, how do we get a rocket to get off in the air? And there's a ton of physics involved in that. And but I pretty much just wanted you to have the experience of building a baking soda and vinegar rocket in a 2-liter bottle and launching the thing off. So the nice thing is you have all of spring break to get this thing done. I mean, because the pre-lab will be due the Friday before spring break, and then the lab is due the Friday after spring break. So you're golden. I mean, you're in tall cotton with this thing. All right, you've got lots of time and you can do it. There is a lot of instruction and a lot of videos in this. As you can see, if I go to this page, oh, there's the thing. What am I talking about now? Oh man, here I go again. There you go again, as Reagan used to say. All right, oh, here it is. It's on my ladybug. I'll show you the sheet that I'm looking at that will be your pre-lab lecture as soon as this comes up. There it is. And I'll zoom. Get in the habit of zooming in here. And plus, you get all of my little clicks in there. See, they're good to see. I know I probably kind of overloaded football, and then there's a little Mythbusters, but they're all good. And those blanks that I know what to record now. So without further ado, you have my own little inertia experiment that I did for my physics of sportsters. I decided to include you all in on the fun. And so without further ado, let's go ahead and knock me off to our slideshow. All right, so we're talking about Newton's 3 laws and jet propulsion, okay? First of all, before we go anywhere, you've got to know what a force is. A force is a push or a pull. Contact force, now see, I've gotten these out of my Physics 210 slides. So we've already kind of elevated the game here a little bit. But, you know, we're in college. You know, I mean, a lot of you have taken science and stuff, so this shouldn't be bad. We've got contact forces, which is like me sliding. You can't see me doing it, but I'm sliding this coffee mug across my desk. I'm actually had to touch it to get it to move. And action at a distance forces do not require contact and include like gravity and electrical forces. Okay. You know, if you throw something up here on Earth, guess what happens? It comes down. Right. So those are your forces. Now, mass is a measure of the amount of stuff contained in an object. Now, I've got a cool video. It's about 11 minutes long on where the kilogram comes from, and not where the kilogram comes from, but where the kilogram is going. Mass, but we measure mass as kilograms. It's how much stuff there is. In other words, you have the same amount of mass on the moon as you do here. What's different is your weight, because the pull of gravity while you're here on the Earth is greater than, and weight is equal to mass times the pull of gravity times the acceleration due to gravity, which we'll get into. Okay, first of all, Newton's first law. An object continues in a state of rest or in a state of motion at a constant speed along a straight line unless compelled to change that state by a net force. Okay, in other words, it's got to experience a net force. In other words, if I have, well, let's just take a look. Let me show you something. Right here, let's take this ink pen or this felt tip marker, this permanent marker that I have sitting on its side. Let's just put it here so you can see it. Sitting there on the table. It's not moving. To get it to move doesn't take much effort because it doesn't have a whole lot of mass. This coffee cup, to get it to move, requires a little bit more effort because it has mass. with the sliding paper underneath it, it kind of moves a little bit easier. But it's got mass. It's got inertia. It's got mass. But look at is it moving now? No. It wants to sit there. But there are a lot of forces acting on it. There's gravity pulling it down. There's a normal force coming up in this direction, up out of the cup, which is caused by the table pushing up on it. Okay, so those are, and then it's got some air pressure forces working all around it. But all of those forces add up to 0, so it's not moving. Okay. All right, and so that's inertia. And now the next, the next few lines, we're actually doing Newton's first law here. I'm going to have to change that, but this is Newton's first law. So what I want you to do is to go watch my inertia experiment, and then I will get into the law. So there's the introduction. We're done.